Okay, let's pick up where we left off last time. So we were looking at 440F. Let's see. Yeah, it needs a name, but it doesn't do much. That would be 440F. Okay. Like it converts the tag cores to the sprite cores and prepares it into the VRAM buffer, but then increases HL. Which should be fine to name it that. I mean, we figured this out at the very end, right? Let's see. Yeah, so 440F does not do much more than take the pointer in IY, puts it into HL, and converts it as tag cores. Whereas if you call this conversion function straight, then it just takes it out of HL, I assume. Yeah, it loads the value of HL into A. So I'm guessing that's just an easy way to go do the same, or call the same function with the parameter being in IY instead of HL. Come on. Yeah, prepare to send to VRAM. I'm going to like take over this name, but reference IY instead of HL. Pointer in IY, because we're pushing that on the stop stack and popping it into HL, right? So that's 440F. And then we were coming from 5B70. So let's get into the game. Let's load the first level or something. And then we'll go back to 440F. Let's run the game. And let's break here, which we do not do. Interesting. I can't remember where we exactly were when it came to breaking in this function. However, I can go look at 5B70 to see if there are any. Yeah, it might be skull related, for example. Oh no, Alma perhaps. Yeah, it was Alma. So let's go to level 4, I think. Level 4. No, it's 5. And we immediately break. Yeah, we do. So 440F is being called from this function here, 5B70, yeah, as we mentioned. And we're in the main game loop, we're calling 5B28. That's a bit above here. Yeah, that's this one. So we check whether the round has started. We're checking the amount of almas in the level. Although the round hasn't started yet, though. And yet we're still breaking on this one. So I'm gonna double check this return. Right, so round hasn't started and yet, and we do return though. That's interesting. So I'm gonna remove this one, and then the call is over here that we're interested in. We do seem to, okay, there's a return here. Okay, so the function starts earlier than, wait, or do we jump there? We might jump there. Because 5b28 does not appear to end up in that function. I'm gonna see where we come from, if I can. Oh no, it's a different function that calls the same 5b70. So this is regular movement of ALMA, apparently. What does a 5b6a do? Oh yeah, that's calls straight here. Okay. Question is, does this function also call 5b70? Let's see if I can see that. 5b6a is called. Yeah. That's the same call to 5b6a, which appears to be the start of this function here. Okay. So 5b6a in this function does not do anything when the round hasn't started, but it is called elsewhere as well. That's why we break, right? So yeah, we are here, but when we look at the caller, we are not in the same function. We are in handle AMA non-rolling movement stuff, which might make sense like it's called right here. Which does load the stuff into the AI slot. So it is handling something. I mean, it is handling AIs, ALMAs, right? And it's probably gonna loop. Do we see a loop? Yeah, over here, 5AAF. That loops all the way back to here, which makes sense. So yeah, we're loading 4 into B, meaning we're doing 4 loops, which is a hard-coded number, which is not the same as the amount of ALMAs. It literally does 4 loops. But this one gets only called once, I assume. This might also be collision detection because this pointer here gets put into collision. D1EC is an unknown. Oh, we have 2 memories open. Let's look at this one. D1EC. Okay, so these are copied into these guys here. So it is collision related, so okay, but we were looking at 5b6a, right, this small function here. So we're updating ALMA sprite during AI, and we are preparing to send IY into the VRAM buffer. I need to reload my symbols here. Right. And then D1FE, also an unknown, which is OC. I remember that is being loaded into A. And then we jump. Okay, so let's see where we jump towards. Also, I'm going to start the game so that we, well, D1FE is OE now. Okay, wait. Let's see what, so it's 10, 12, OC, OC. It's strange that that changes though. It goes OC, OE, 10, 12, and it draws back to C. That's a bit weird. But fine. So now we're here. Let's see where we end up in 6426 here, though. Let's see what that does. What that does. Okay, DOOD, that looks to be yeah, that's also related. Oh, that's the VRAM stuff, right? So we're copying 4 bytes here, probably from DA05 being the oh no, DA05. Wait, that's quite DOA5. Okay, sorry, DOA5, which is Alma's sprite. Yeah, so this is just copying stuff into these into this preliminary VRAM pointer, I guess, which is copied to VRAM. Yeah, okay, I need to give that a better name as well, because these have same values. Like these are going to be the same. I'm going to let this copy do its thing, and then we will compare the values here. I don't see 47 though. Oh no, it's 0047, which I assume is an YX position, although this might be in a different coordinate system, right? So let's see. I'm going to go to construction mode and get myself a single Alma. That's going to be easier to compare stuff and to find out positions, location in the level. And I'm going to put it at 204, meaning top left, so I can investigate the values. I mean, they will be more recognizable, right? Okay, so now we're not breaking, but we will be. Okay. Yeah, so that's 0007. That's going to be positions, right? So 0204 is the Alma XY position, but we convert this. And I forgot the algorithm. I need to put this algorithm here though. So, well, no, it's not this function, but this function. So if we go to 657A, then we can see we double m minus 1. So sprite y equals tile y times 2 plus 1, and sprite x equals tile x times 2 times 2, and that's it, right? Because we're loading the second one, we're loading the second byte, we double again, and that's it, right? Okay, so what would that mean for 02? That would mean becomes 4, 8, that's 9, and we don't see that here yet. That's unfortunate. Did we execute the function already? Yes, we did. So yeah, we do have in our AI slot, we do have 0204 though. So I'm gonna break one earlier. I think I'm breaking in 2 different locations here. But fine, let's just pick one and let's see. So we are still on 0204. and that would become for 8, that's 9, which it isn't, and then 4x would just be times 2 times 2, and that becomes 816, which is 10. This is 10. Oh yeah, no, this is key held. I was looking at the wrong one, so 5710. So might we be looking at Lolo? It could be though. So let's calculate Lolo's position. Where is Lolo's position again? That's up here, I think. Is it not? No, that's level stuff. Yeah, this one here. So 1604. Yeah, 04 becomes 10. So 16 is, that's 16 plus 6 is, of course, 22. Times 2 is 44. 88 plus 1 is 89. Let's convert that to hex. That should be 57. No, 89 decimal is 59. Wait, did I make a mistake? So I said 16 hex is 22, right? Yes, 22. 22 times 2 times 2 plus 1 is 89. In hex is 89 hex is 1. No, 89 decimal is 59. So why is it 57? Did I not look at the algorithm correctly? But in any case, we're handling Lolo now. So, which is weird because this might actually not only refer to Alma's sprites, but also to Lolo's. Yeah, probably because I don't think we're talking about Lolo now. Well, no, because the AI slot does indeed contain 0204, which is the top left position here. Although I didn't execute a function yet. Wait. Yeah, so the previous value would have been 5710. I don't know why it's not 5910, but sure. And now we're going to execute a function, and we get 0710, meaning 2 becomes 4. That should be 9 though. Let's look at the function again, because I think I make a mistake here. So we're loading HL, we're doubling it and doubling it. Oh, and removing one. Why did I put +1? Yeah, we're removing one. Yeah, I think I looked at this increment here. And then X is correct, right? Because that's just 4, meaning 8, 16, which is 10 hexadecimal. So that's correct. And is this matched now? So we have 2 becomes 4 becomes 8, minus 1 is 7. Yeah. And that's the same with Lolo's position. That's why my calculator was wrong, because I need to do 22 times 2 times 2 minus 1 is 8, 7 is hex 57, and that was what it was. Okay, it was 57. So yeah, that should be a minus indeed. Let's go back to where we are. Yeah, I want to know whether this function is called with Lolo as well. So it's easy to see whether this function gets called when there's no Alma in the level, right? So let's continue. Let's go back to construction mode. Let's remove the skull just to be sure. Let's play this level. Okay, it's not triggered now. That's quite interesting. That's interesting. Wait, I did enable it, right? Yeah. And we're not breaking here either. Nor here. Okay. So it is Alma related though. that's interesting. And we immediately break because there's an ALMA in the level. Yeah, because we did see that ALMA was in the AI position, in the AI slot. So now we have 1604, which is Lolo's position in this function here. The level hasn't started, so our function up here isn't calling this, doesn't make this call, right? So let's see where we are coming from. Right, and that's the same one we are looking at before. It's the ALMA non-rolling movement, which would make sense because we are right on top of him. We have to track Lolo, right? Right, and here we are putting these hard-coded values into D1FE, what we were looking at before, and D212 gets 1 in it as well. Okay, so I think it's more interesting to look at this function because it calls the function we're looking at anyway, which we didn't figure out before either. And yeah, so we update ALMA sprite and prepare it for VRAM. Okay, where are we? Oh yeah, we're broken the top one there. And then the jump, I just have to look what happens after this jump here. Right, that was copying, and then we're calling a block transfer, and we return, right? Or do we something? Yeah, we're doing a couple block transfers, and we return. I think, yeah, so let's give this a name, or a better name. I mean, this is prep for VRAM Y and X, and I'm assuming it's going to be the same, like the same pattern, right? Y and X, so Y and X, and then we have a direction which we don't have here, so that's an unknown, I assume. And it was 7 bytes, right? So that's all the way here, and then we have one over here that we don't know about. So I'm gonna assume it's 7, because I think we address all of them. I mean, I think it's a sprite though. 58 is 88 decimal. I think that's a sprite. 88. Yeah, that's the eyes. And that's indeed Alma's eyes looking forward or looking down, I guess. So yeah, that is going to be sprite. And it's going to be sprite 1 because, and the color and sprite, yeah, of course. Same as always, sprite 1, color 1, and then and a sprite 2 and color 2, because if we look at the second sprite, that's going to be the Alma body. What did I miss? Oh, were there not supposed to be semicolons? Wait, D009. Oh, did I? Okay. Have to do the hex, of course. Oops. OC. Okay. And OE, obviously. Okay, so now these have values too. Yeah, so 54 is going to be the second sprite, is going to be Alma's body. 54, I mean it's 84, so it has to be, yeah, this one, standing still, makes sense. And color 8. Okay, so this just, I think, copies these values into the prep area from the, I don't know, it can come from here as well, of course. And I mean, it does 2 block transfers for some reason, which is fine. But let's go into it, right? So for VRAM sprite 2, that's this one then. And we're copying 4 bytes. Well, I mean, 58 also looks like a sprite ID and a color. And we're copying 4 bytes here. So do we have a third sprite? Because yeah, DOOF is referenced here as well. And that's the last one. Let's add it, but it's I don't know, iffy, not 100% sure. So because we have the third one referenced here. Okay, so let's go over it. We're copying with LDIR. We're copying from what HL points to is DOA5, which is this first sprite. It's weird that we are pointing at the second sprite, so maybe it is not. This is not sprite 1, but this is sprite 1. That's a bit strange. Although we do use that here though, okay. Yeah, we're writing something. Not sure. Okay, so we copied that, and then we're loading again the pointer to sprite 2, and we're calling a function. Let's take a peek what that does. That does quite a bit. Wait, oh, that was right below, was it? Get facing direction if, okay, that returns here. 6426, oh, it calls this, wow. So if I escape now, we return here, I guess, 6435. Yeah. Oh yeah, so it calls this like it's like a little inline function or something. Because after this one, oh yeah, now we're loading sprite 3 and doing the same routine. Okay, so we're applying this section to both sprite 2 and 3. And we're popping AF. Okay. And then that becomes D, sure. Now we're pointing to the third sprite and doing the same thing as we would have done here. I'm wondering which pointer gets. Yeah, it is the Y that gets. Wait, so does that make sense? We need to do 2 block transfers. We're doing the second one now, and we're keeping. So we have 2 sprite color combinations. And first we do the first one, then we do the second one. But the thing that actually gets copied to VRAM is this first slot here. So yeah, we store these values, and then just before copying to VRAM, we move those into the actual position, and then we send it off, and then for the next one we take the other one. it's interesting. So we've loaded sprite 3 now. Okay, let's see what this subfunction does. So A is now OD. We incremented the accumulator here, which was OC, which suspiciously looks like this value here that we were referencing before, right? And we're doubling and doubling again, and then loading that into the DE 16-bit value. So let's see what it ends up as. That becomes 34. Oh, but we're adding stuff. Okay, we're adding stuff to 1B, right? Because we're adding both the 16-bit values together. And now we have 1B, 3, 4. Okay. We have the original pointer again. We're loading that value. So that's the pointer to the second or the third, I guess, sprite color combination. And we are loading both those values into, so from these two to these two, the one we want to send to VRAM, makes sense? Right, increase loading, putting into the prep color variable. And then we load the base pointer, which is the start of it. And we are copying 4 bytes, which would be Y, X, sprite ID, and color, right? So these two are placeholders. So this is placeholder sprite 1. Placeholders to because the thing that gets into VRAM is only the 4 bytes. Only the first 4 bytes get sent to VRAM. The 2 sprite color slots after are for holding the 2 sprites that get sent in, well, it's not in one go, it's 2 calls. Well, no, so that's not get sent logically. For example, eyes and body, right? So we're doing this at the same time. And we probably have to calculate which of those sprites that is based on Alma being, oh no, we do have 2 sprites here, right? So we just copy those over. Yeah, 5408, 58OF, that's simply copied over. Okay. So then we do call that, and we put that on screen. Okay, so that 34 wasn't really coming from our OC here, perhaps. That wasn't really clear, and we're doing divide by 2, ending it, taking the top 3 bits, is that correct? Yeah, taking the top 3 bits. Oh, well, that affects the F register, of course. Well, loading A into E. Six, 4, 7, 8. That's a function pointer to here, I assume. Loading D, oh no, adding together, okay. 6, 4, 8, 5. So we're pointing now here. Loading the value of HL. But that would be 13 here, wow. Yeah. Why are we referencing code like that? Because it's literally, unless this is, yeah, these are probably just bytes, like data, instead of code. And that's why we have increment, decrement. That doesn't really make sense, I think. Maybe, because we return it anyway, right? So we duplicate or double A and double A again. Add 80 hex. That looks like an interesting number. That's 128. Which happens to be half of our sprite things like slots. Oh, we're doing another block transfer, okay. Into a different part of memory, perhaps? Because, yeah, we're loading again 4 bytes into VRAM. I didn't look at the pointers where in VRAM that got stored. So that's in DE. That determines where in the VRAM we're storing this. And that's now 1BCC. Okay. So we looked at this function here, right? So this is 6426 moves the 2 placeholder sprites into VRAM. Yeah. Okay, we continue. So we exit this function. Why did I not see that name change? Was that inside? Oh, no, it's here, it's here. Where's the PC? Does 5B6, yeah, 5B6A calls that. Okay, yeah, that's what we were looking at. So this simply updates Alma's sprite based on its movement and stuff, converts it to sprite coordinates, and puts it on screen. Meaning, so if we remove 5B6A, we wouldn't paint any Almas, I assume. And so, wait, let's run. 5b6a is now called from the non-movement stuff, right? Or we're not in the, we haven't started the game yet. So let's see, yeah, that was this function here, non-rolling movement. Because we do have to paint him, even though we're not running yet. But now I'm going to start the game, and then he's going to start moving. And now when we see in which function we are still in the non-rolling movement. And now we are not. So it is. Oh no, we are. Okay, that's called at the top here, and apparently a bit lower down as well. 5b6a. And the third time, I guess. Or are we here? Oh, no. This is the function 5b28 where we were looking at. Yeah, that's the third one. Okay. That's the one that got skipped over because we weren't running the game. So this is just an update Alma and render, I assume. So let us give it a name first, right? So we have something to go by. 5b6a. B6a. Okay, and now I'm going to try removing those, or at least one of them, by, can I just return? I don't think so, because we're jumping here. Yeah, no, I can't really return, so I'm just going to knock this one out. So let's see, where are we? We have to knock out this one. So let's start from CD5265, CD5265, CD6A5B, DDE1, DD23. That should only occur once, which it does. And then we have to remove CD6A5B. I mean, it might crash now because it might expect a return value from this one, so I'm not really sure. But let's see. Let's load the hacked state of level 4, 5. So they do render now, and they keep rendering. So I'm going to remove one more. I'm going to put them in rolling state. Perhaps it is, no, rolling state does work as well. I'm going to look at my function here. No, that wasn't a function. So this one, 5b6a, is what we were looking at. And it was up here. Oh, no, it didn't. Wait, did I remove this one though? Why is it not applying? I loaded a hack. Oh no, I didn't. I probably didn't. Yeah, it's missing frames now. So it's the intermediate frame. Yeah, where he's walking. I wonder if the rolling still works. Yeah, that does still work, apparently. So yeah, this is definitely updating Alma's sprite and rendering it. So let's, I mean, just to be sure, let's remove some other ones, because there were 3 calls to this function. Yeah, now we are knocked out. So we had another one here, this one, and did I skip one? No. So we have this one here and this one. Okay. I'm going to take the same ROM, which has the 3rd occurrence removed. I'm going to remove the other 2 as well. So we look for CD9143, CD6A5B, CD6343. 1 occurrence, that's good. And we remove CD6A5B. And so if I save, yep, that immediately gets updated. And now this one, we're looking for D5 CD6A5B 3A13D0. And that is this one, CD6A5B. Right, and they immediately stop painting. So they still move, but they are not updating at all anymore. Okay, that confirms what that function does, which is simply updating the sprite and rendering it to screen. Excellent. Let's load the normal level now and go back to our function here. Yeah, so it actually is update Alma sprite and render it to the screen. Good. We didn't figure out what D1FE was, which is given as a parameter to this function for some reason. Do we use that in this one here? It doesn't look like, though, because we're starting to copy memory. We are calling something here, that's fine. Although, well, we're pushing it on the stack, so we might be using the accumulator here. I do want to try changing the value that gets put in there, which was OC, right? If you look at this, I think it's this one here, was it? But let's start the game. Maybe this one, I can't remember what exactly it was. Let's go to the, well, no, the game isn't breaking here. D1FE is what we are looking at. Yeah, this one here. I'm going to, so here it is red, but I want to see what happens where something gets written into it. And that's not in this function. Right, that's just a convert function, right? I thought I saw those functions being, or was it this one perhaps, where D1FE got written into. Wait, again, we were in our copy function. And then we call something immediately, but that's right down here. Right, we're doing this just twice. Okay, so this call function is just over here. That's not important. And yeah, this was the data we were referring to, which starts with D1, which is an interesting value because that's what we sometimes see appear in that address. So I don't remember exactly where that value got set. So I guess we can put a watch point on that and see if we can break it. If we go looking for D1FE, Boom. This is collision detection. Okay. So we're loading OC in here. That's a weird value because why OC, right? That's like, what is it, 13 or some 12? Unless that is like a sprite offset, perhaps. I mean, we will start here, right? So we have the two walkies and the eyes, two walkies and the eyes, two walkies, two walkies, one standing, and the eyes. And that's the 12, difference of 12. So if you go 64 plus 4 plus 4, that's just 8, right? So it can't be that. Unless it is this one, 76. That's 88. Does that? Yeah. So it could be the amount of adding we have to do from the base pointer of the set of animations, right? So in this front thing, we have 4 facing front, and we need to reference one of these 3 and the eyes. And the distance between the first and the eyes happens to be 12, which is what we are writing here. I mean, that would, I mean, what's the other one? So the other one would be 8, and I don't think we see that value often. So let's see if we can trigger it some more. See if what other values come up. So at this position, we write 12 in there. And now we're increasing it. Well, no, but then it becomes 13. So that's not going to be, that doesn't make sense. So we're increasing it twice. That's weird because now we're counting up. And again with OC. Okay, let's just force this value to something crazy and see if we see a change. I have to do this in the hex editor, of course, because that's in the ROM as well. So we need 3EOC 32FED1DD2131D1. Okay, that occurs twice, sure. More than D1 is the last one, C5DDE5 FD. Okay, it's this one. And we need to change 3EOC. This is the value, so it starts with 12, right? So let's put in a random value. Let's load the hacked ROM, disable the breakpoint or the watch point, and let's load the hacked ROM. And start it, and it doesn't do anything visually different, of course. I mean, it was in the rolling animation though, so let's see. Yeah, now it's messing up. Okay, so if it's only in the rolling stuff, what does 12 have to do with the rolling animation here? Because it's just 2, right? There's just 2 animations here, 2 sprites. But it's definitely like sprite index related. Because now if you look at our values here, oh, it still goes quite a ways down though. So let's put our watch point back into play. So we are indeed now at my value, 55. And next iteration, we do increment 57, 8, 9, A. And we go back to OC. Oh, there's another one that puts in OC. Okay, I want to change this one as well then. Wait, what address was this? Do I still have this? I think it was this one, yeah, 3E. So we are, what's my address here? Why is it 0? Oh, it's a colon. Okay, where was I? Here, it's 19B0. Okay, 19B0. And then let's find this guy. 3EOC 32F. That's going to be the second one that we just found. That was the duplicate. Yeah, so it's this one. No, it's 3EOC. Yeah, so let's put this one on 55 as well. Yeah, that changed. And let's not. Oh, it's already messing up here too. Okay, never mind. Yeah. Now it's doing quite weird stuff. Now it's even doing weird stuff in the normal movement. Right, that does make sense. We have a function for normal movement and we have a function for rolling, and this is the non-rolling movement that I now changed, which is now also messing up. What was this address? 1A70. And I have the other one here, 19B0. Yeah, that's this one. So let's now put it at a bit lower number. 1A70. What did I take? 5? Yeah, it's hard to tell what exactly that is, because it doesn't shift to other sprites, right? So it doesn't suddenly take like something completely different. So it's definitely not an index in this table here. Weird. It's very hard to tell. Let's reload this level. So it doesn't affect them standing still. Yeah, but as soon as they move, like it looks like it's delayed. I mean, I'm gonna add it. I'm gonna change it to one more. So it was OC. Let's put it at OD. And where is this one? I think it was this one. Yeah. So question is the right facing Alma next to the rollers? I don't know. No, not even close. The rollers are here and the right facing ones are here. Okay, so it's a bit hard to figure out what that value does. Now, question is, does it? I mean, I don't think it'll affect anything else than Alma. Right, it doesn't affect. It doesn't affect the skulls, which are also moving around, right? What else do we have that moves around? These guys, perhaps, because the fireballs, no change. So I think, yeah, I mean, I'm gonna put Alma related, Alma sprite related, but I don't know what exactly it is. Let's go back. So D1FE. Yeah, it's something to do with the sprite sequence. Because we do have some booleans here that are enemy related in the same area, but yeah. Okay, so let's reload that. That's also weird. Well, not necessarily it returns here, but because this is skull related and also references this value, and we're loading 2 in it, so it's not just for Almas, because this is skull targeting, and we didn't see any change though. Because now we're loading 2 into this function inside the skull targeting stuff. That's weird. So I'm going to go back here. I'm gonna log the skulls in if I'm not on time. Well, they won't come up. That's interesting, because if I go look again, I don't know if I removed these values at the bottom here already. Of course I did. So if I mess with these values again, apparently, well, first of all, they should be oh yeah, no, I didn't mess with those values because the 55 and stuff that I put in there, I did in the code for Alma, right? So if I go to the skull stuff, that's still 2. Yeah, this guy here still loads 2 in it, right? If you look in the memory here, now it's 4, and I'm gonna put 2 in it, so that probably goes 2, 3, 4, perhaps. Wait, no, yeah, now here we're putting 2 in it, right? So actually I shouldn't break here, I should break here in the watch point and see what gets put in there. Yeah, so we go 2, 3, 4, and back to 2. So, I mean, it must be sprite index related, or how can it not be? It goes 2, 3, 4. Where are the skulls? Wait, are those just tile related? Oh, no. 2, 3, and 4. Weird. So let's mess with these values too. So we're looking for 3E02, 32, FED1, CD55, CC8. Okay. And now we have this O2. Let's put our crazy value here, 55, and let's continue. Now, yeah, these are messing up too, so it's not just Alma related. It's weird. Nope. Now it's 1. Wait, does that not have an effect? I'm gonna put it closed though, so we can't escape. Yeah, so 1 seems to be fine. 0 makes a mess of it. And 2 is normal. Ooh. Okay, it can't handle the reload, I guess, because the entire thing has crashed. Okay. Core dumped. That's fine. That's fine. Let's reload our state here. I think it was this one. Oh crap, I lost my add one to T1FE. Right, that's the one. 5B8. Well, no, it's 3A, 3E. I have to search again. Yeah, it's this one. So if I put it on 3, I'm going to put it back on 2. Right, so they are functioning normal again, except for the one that got left behind. That's fine. Let's see if Lolo is affected as well. I'm going to load a constructor. Do I have constructor state? I do not. But that is fine. I can go to the first level or a level without a sprite in it and see if this gets overwritten. No, so this D1FE is only used for enemies then, sure. And, oh, now it's 17 for the fireballs. Yeah, so fireballs are affected as well. And 17 is 23. And so 17, let's see how many iterations we have. So we're at 17. Wait, does it stay on 17? Or do I need to trigger a fireball here? I might need to. Of course, I put myself in danger here. Nope. Of course, I wasn't fast enough. So we're still on, where are we? No, we're clearing the level. Okay, never mind. So I do have to put the block here so I don't die. Okay, it immediately starts. That's good. We have 17, but I'm gonna trigger a fireball now. Yeah, so now it starts moving. I'm just wondering how many iterations it does, whether it's different for 17, 18, 17, 18, no. So for Almas, it was like 3 or 4 iterations, and for this one, it's just 2, 17 and 18. So I do wonder now what happens if I remove the increment. So here we're loading the base value, that's fine. But what happens if I remove the increment here? So let's look for that. It's the 34 is now gone. What happens to the sprites now? No difference in fireball sprites, which is also weird. So that value now never changes, right? That's day 17 stable. I am wondering. This is a function that uses that though. A sprite sequence related is loaded into the accumulator. Something is called with this as the first parameter, and then the result is loaded into HL incremented, or no, we're incrementing the value then simply. So 6438 does something with that. Oh, okay. That's interesting, because that we've handled this function just now, right? This prepares or copies the prep stuff for copying to VRAM. I better give this a name too. So first of all, this is not Alma, but mob sprite or enemy sprite related. And then this guy, I think we can, well, no. We might call this one as well here. It's one of those functions, I think, where you can call at 3 different positions, and then like if you want if you want to act on one of them, 2 of them, or all 3 or something, you call at different points, but they all the body of the function is the same. Because yeah, this is called from here. So this call does that for sprite 1, and then sprite 2 falls through and does the same thing for the second sprite. So and this just wait, so what do? We load the something into HL, and 643A saves that, sure, and uses the accumulator. And to make an offset into something like the destination for the VRAM. Okay, that's being calculated here because that's in DE, right? We're exchanging HL and DE. Okay, and then we're loading what it was, meaning which sprite, which not sprite, which well, yeah, which sprite and color combination is going to be copied into VRAM. So the only thing this does is it calculates the offset into the VRAM based on the accumulator, as in where to put it. And then takes what HL points to, the 2 bytes, copies it in our prep for VRAM, and moves our entire YX sprite color struct into the VRAM. Right, so 643A copies prepped for VRAM into VRAM. Right. And that is called here too, apparently. Okay, we're not broken. Need to create a fireball and add the watch point. Okay, that's the start. Okay, so 17 is our base. Oh, did I knock it out? I knocked it out. I need to be in a normal one. Unless I just undo this here. Right. Now it should trigger on the next one. Yes. Yeah, so let's see what the accumulator has here. Enemy sprite sequencer. Ooh. Because that's now in the accumulator. So that's an offset into the VRAM. Right. Right, because over here we are doubling and doubling the accumulator, which is this value that we're looking at, D1FE. We're loading 0 into D and the calculated value into E, that's fine. And adding 1B00 to that. So it's 1B00 plus the accumulator, this value times 2 times 2. Okay, so 24 is the current value in decimal. That's 96. Okay. 96 is added to 1B00. So is 1B00 the base of the sprite thing here? Because 96, what is 96? No, that's not that. Because there's no ALMA in the level here. It's definitely not a pattern index or a sprite index. I mean, it would make sense though. But unfortunately it isn't, because we're talking about the fireballs here, which are over here, like it's this one or this one, 20. Wait, so 18 was what? It's 24. That's downwards, no. Well, it wouldn't, it would be the sequence of these, which it would never be. Also, this one doesn't change unless this stays 17, unless it hits. But I don't think that's the case either. Right, now it's again 17. Okay, let's try again. Okay, now it's 18, 17, 18, 17, 18, and it doesn't update. 17. Yeah, so it gives that, like that's literally an offset into VRAM, right? So I don't know what happens when you write that specifically at that position in the VRAM. We can take a look at this. I go to 1B00. And we are adding, well, I mean, let's see if that gives us any indication. I don't see anything changing, but we might be off screen here. So 17 becomes times 2 times 2 is 5C is 92. Okay, so 5C plus 1B00 is of course 1B5C. Okay, that's 1B5C is this one. But I might be looking at the wrong thing though. Yeah, because that doesn't change. No. One B04 is the address. That would be this one. I don't know, that might not be in the main memory though. I might be looking at the completely wrong thing. If I look here, if I look at this, maybe this is the one that shows it. We're looking at 1B. Oh, 4. Yeah, this might be better. Yeah, let's see if that changes. Yeah, it looks like stuff is changing here though. So yeah, what was it that we were looking at before? Because wait, so let me disable this one and let's do the calculation again. So 17 17, let's see, again, well, 1B5C was my calculation, right? So 1B5C, yeah, that's exactly this one. So it is doing stuff here. I wonder if I can change this. That would be interesting to know. So this changes from 47 to 3F. Okay, there's no fireball now. 67, 5F, 57. That's interesting. I don't know what these values mean, but wait, are these YX? Yeah. This is YX sprite and color, right? 14 would be 20, which is a fireball, I think. 20, yeah, that's the up. Yeah, that's effectively YX. So if I make that makes it blue. Probably on the next iteration. Well, no, it's copying it as well. It did stay. I guess I can't update that simply like that. Okay, so oh, is it? Wait. Okay, so we're loading 17, right? 17 is hex 17 is 23. We're doing times 2 times 2 is 5c. Okay, so that's the pointer that we have to put this here. Makes sense. Then so that's our 17 here. Then when we iterate, we're incrementing it to 18, making this 18 hex times 2 is 60 plus 1b00 is of course 1b60, which would put us in VRAM 1b60 4 bytes later, right? So we're alternating between sets of like structs of 4 bytes. That does make sense now, I think. But the question is, what is this thing in the VRAM? Like it's a YX sprite color struct. But what does it affect? Because I can't really change it for some reason. And they're always put in these two slots. So these are the VRAM fireball slots. Because that's what the 17 does, right? That's the hard-coded 17 that places them there. And every enemy has their own sprite slot. Well, the Almas and the Skulls have their own slots. And I think Alma had like 4 or 5, meaning 4 or 5 sets of 4 bytes. And Skulls had like 3, I think. That's interesting, but how can we manipulate that, right? So I do want to change the color, but I think it's not going to work if I just put, I mean, it doesn't turn blue, right? Oh, and this one does change, but it doesn't take the color into effect and the sprite index. Wait, so we're looking at YX sprite and color. And this one stays. That's weird. And this one has the same stuff in it. I mean, it is position related, right? Let's do another one. Right, so it's the same memory location, but now Y stays the same and X increments because we're going toward the right. And they all follow the X position here for some reason. Okay, how many times do we increment? So we're starting at 17, we increment, and we're back at 17. So it's just 17, 18. Let's try a different animal here, a different mob. I'm going to go back to the normal ROM. So we definitely don't mess with our values here. And I need a thing, yeah, this one, right? This is a complex one because it has 3 almas, but we're going to see 3 positions. Yeah. So we're seeing 3 sets of, wait, how many breaks do we have? So we start with OC. So 12 is our base for Alma. We are incrementing, so we're looking at here too, right? OC. We're incrementing that. Oh, that's twice in one go. Because now it's OD and we go to OE. Right? In one go. Meaning we're skipping 8. Which might make sense considering what we're seeing here. Like these 3 sets of 8s were moving, right? So we're going to 12, which is 16, and 2 is 18. So we're going from 12 to 18, which is 6 increments. And do we see that 6 increments? We have 1, 2, 3, 4, 5, 6. Yes, we do. And there's 3 almas on the screen. Yeah. Only thing is, like, what are these values? I can't, well, I do. It did turn blue very quickly. Let me, so this was eyes, which we couldn't really see. This is the second alma body color. I mean, I don't think yeah, it does change. For a very brief moment, it changes blue. So this is indeed the color of the thing we're having on screen. But now the question is, why this position specifically, right? And let's look at the sprites again. So if we're looking at, right, so the attribute table starts at 1B. That explains a lot, because 1B is what we're adding to our calculated OC here, right? The 1, 2 and stuff, right? So it's simply the index into the attribute table where we have to copy the AI values. Why it is all the way down here and not with the AI stuff beats me, but I think that's what it is. So yeah, let's pause. Nope, pause. And so yeah, attribute table is at 1B00. And we are offsetting within 1B00. And that's the value we are updating in the VRAM here, where we are pushing our VRAM data. And that's just a multiple of 4 bytes, right? Okay, so now we can give that a better name. Where are we? I'm gonna go back here, enemy sprite sequence. Yeah, so this is VRAM attribute table offset for enemy sprite update. That makes slightly more sense. So yeah, it is indeed a calculation within that table that we're updating. So yeah, we figured that one out as well. We have an unknown here though. 218 might be related, because I think when we are set, well no, this is where we are setting it. Wait, so does that mean we have 10 positions for Alma? Because we have potentially 10 Almas in the VRAM. No, I need memory VRAM. 1B00 is base. I guess, so yeah, we have 3, 4, 5, 6, 7, 8, 9, 10. I mean, I'm assuming there's going to be 10 slots for 10 Almas here. And probably in the initialization of the game, these sprites are associated with these positions in the attribute table. What else did we have? We have another one, another offset here, right? So we have the attribute table and the pattern table. So 3800 is going to have at the same offset probably, or something similar, same index at least, Alma related stuff compared to what is here. So that's how they are linked, I assume. So yeah, 3800. Okay, here we have the patterns of the sprites. So yeah, I mean, I can't change them because it's not a bitmap, right? It's not a ones and zeros. It's like compressed into bytes, I assume. But yeah, that's indeed our index there. So let's see. I'm going to exit this function though, so this is fine. So 440f, we gave a name. Yeah, that's our conversion. No, 440f. Oh yeah, that's the one in IY, I think. Yeah, pointer in IY. So we have got that one, and then we are coming from 5B70. Right, and that's update almas and render, which I gave a name, nothing unknown here, and then we're coming from 5B28 in the main loop. That doesn't make sense. 5, I think I made a typo there. Oh, no. 5B28 is the function called start. Yeah. So if I stop there, I will be able to exit. Oh, we haven't given that a name either yet. Okay, so let's exit. Let's look where we are in the game loop. Yeah, that's our 5B28 here. Because we're in the main loop here. So let's see what 5B28 does more than what we were looking at in depth here. So it's ALMA related. That's the OC again. Okay. And is this not simply render almas? Render alma sprites. I can't remember what happened if I removed that function, but if there weren't any almas in the level, then I wouldn't have seen a thing change. Because I think, yeah, so let's go back to where we call this in the game loop. Okay, so let's break and escape. And let's copy our hacked ROM. Yeah, I think this is just render the ALMA sprites, perhaps. Okay, so we need to remove CD285B. Okay, and then we will go and look at the hacked ROM of level 5. So they are there and they are moving, but they are not rendering properly though. Oh no. I mean, they might still be moving. I don't know where they are. I'm probably gonna get killed. Yeah, no, they still are there. Right, I did do this. Oh. So it does more than, I mean, it's not just rendering. Because they did render, right? Like, that's the weird part. No, well, okay, so does it do something if the round hasn't started? It does not, okay. So we want to put that, and then there have to be almas in the level, okay. So let's do that and then start a level. So this starts running. Okay, so we get almas, the pointer to the alma data. And then the OC we now know is for the attribute table, the VRAM attribute table offset. That's fine. We're loading the X state. Wait, what was put in the accumulator? Oh no, we're loading IX points to D131. That's going to be the X state. Okay, so we're loading the first X state for the first ALMA. We're seeing if it's 0. So we're skipping if it's in X state. That makes sense too. We're getting the facing direction, all going to be right now, which returns 3. 3 is right, I think. Yes, 3 is right. So we got the facing direction of the first one here. Okay, we're updating the position, so we're moving towards the right. And we're updating the sprite and rendering it, sure. Of course, not yet. We're popping IX, that's fine, which is the base pointer, which we increase to the next one. Wait, D132 is pointing to X position then, I assume. D132 is, oh no, that's ALMA2 X state. Okay, yeah. So IX points to the X states and IY points to the data, DOA2, which is the first position, but we have to increment by 8 because we need to end up at the next ALMA. So this little loop will update all the, but that's it though. Wait, so it updates the positions, updates the sprites, and renders it. So how did we get moving ALMAs on screen whilst I knocked out that function though? That's weird. Unless that's called from elsewhere. Okay, so we're going to the next ALMA now. So now we're pointing, IY points to DOAA, which is the next one, right? Yeah, ALMA2 Y position, which is skipping all these bytes. And okay, we're updating our value in, or our index into the VRAM attribute table. Also makes sense because we have to point to the second ALMA. And we're looping now the second ALMA, that's fine. Okay, again, facing coordinate, direction, I mean. Loading it in the AI slot, updating the position, updating the sprite, and going to the next one, okay. And then we return. So this, why would that doesn't make sense. Okay, so we're out of ALMAs, and we return. This literally updates, like does ALMA movement. Then why do we, maybe these guys also influence that. So wait, OX 5B perhaps. Do we have a 2? We don't. So 5B to 8 is handle ALMA movement and rendering. Well, so yeah, it's based on the direction it's facing. So this is not the AI, as in there's no targeting here. I think that happens elsewhere, right? Oh, yeah. Wait, so we have non-rolling movement as well. We have rolling collision, which we do twice. And then we have a handle non-rolling movement. Wait, which does the exact same thing though. It updates the sprite as well. Yeah, so they split up the game loop into 2 sections for some reason, and I don't know why. Like, they do AI stuff first, and I think based on the changes that happened, they want, in the same frame, they want to update again for some reason. But yeah, that's why we saw ALMA movement, I guess, because this one does update as well. Remove entity from map. Okay. Oh yeah, this could be, well, I mean, I don't know where this function exits, but we're doing skull targeting here as well, though. That's also weird. Unless skull and ALMA targeting are the same, though. That might also make sense, so we'll have to look at that too. I'm gonna first give this a name, which I already did, I think. Yes, handle ALMA movement and rendering. So yeah, so that's another unknown that's gone. And now I want to look at this because this looks weird. Let's see if we stop here. Yeah, we do. So this is not skull targeting, this is general targeting based on Lolo's position. What's my second breakpoint here? I don't seem to have one where, okay, yeah, here. Yeah, so we're gonna disable this one. Okay, let's look at this one again. Skull targeting checks whether it's a bonus level. No, I wanted to go in there. Okay, it checks whether it's a bonus level, that makes sense, which we do not have. Oh, and this is an unknown in skull targeting AI, which is D208. D208. Yeah, this is going to be for Almas as well. We're loading this into another AI unknown, of course, which would be up here, right? No, where is that? D2, no, current AI slot Y. Oh, no, okay. We're loading D208. Into IX, at least a pointer to that, I assume. Yes. And then the current AI slot Y, that will be Alma already, I think. That's this one. 28OE, that would be the third Alma we're talking about now. That's this one, right? That's, yeah, Alma 3. And Lolo's position. Okay, that makes sense. And this does the targeting calculation, right? So this is not skull targeting, this is general targeting. I do have to figure out this algorithm though, because if I want to remake the game, I need to know how they exactly do this. So it's comparing the current AI or the current position versus Lolo's position, being respectively in HL and DE, and then this targeting unknown also affects this calculation because, oh yeah, this is an array of like 4 bytes, right? So we have 4 unknowns here, and we are targeting them. So it's in IX, and you can see we are targeting byte 1 and 3 and 0 and 2. And right now these are 01, 2, 3, but they might change. I mean, I might as well look at it, I guess. But it would be handy if I had a comments column here where I could put some notes, but I still have to add that. So do we jump here? Yeah. So I think this first one is going to check either whether we're above or below or left or right from Lolo, as in from the perspective of the mob, the enemy. So let's see. We have all the things loaded, right? So we have HL as the AI slot pointer, and DE has literal position, I think. Yeah, that's our position. That's 06OE we find in DE. And HL contains the value of DO11, which is, okay, so we literally have the values. We're working with XY coordinates, not with pointers. So yeah, this is the mob and this is Lolo. We're loading D, meaning the Y position of Lolo into the accumulator, okay? Wait, no, they switched. This is X, so here is XY. Because of endianness, this changes from YX to xy. Okay, so this is x position of Lolo gets into A, and we're subtracting x position of the mob. So we're checking whether it's to the left or to the right. That's going to be 0 because they're both OE. I mean, we're in the both in the, or all three in the same x position, right? Okay, I think sub H is going to put something in the 0 flag, perhaps. Yeah, subtracts H from A. And I mean, it doesn't say where the result is put, but I'm assuming it's in the accumulator. Right. So let's see. I think this is going to become a 0, which it does. Yes. And then we're loading A into D. Oh, so we are updating our Lolo position, meaning we are getting a relative offset to our to Lolo in the Lolo position. Fine. And that hardcodes 0 and 2 in these in position 1 and 3. So this becomes 0 and this becomes 2. And we haven't done our conditional jump yet either though. So it's unclear based on what we've done what these values mean. Okay, so we're putting 0 and 2 there. Okay. And so the JR is going to be jumping based on the subtraction, I assume, right? So our subtraction carry as defined, PV detects overflow, so JR and C. Let's see what that looks like. Looks at JR and C to a value. Okay, don't go off screen. If the carry flag is unset, then we jump. If the carry flag is unset, okay. I don't think it is because we didn't cross the 0 boundary here, right? We just did. Our result was 0, so that wouldn't be set. Okay, so I don't think we jump. Oh, we do. Okay, it's NC. It's the inverse. Okay. I think I looked at the wrong one then. No, I did. Oh, if it's unset, and it was unset, so we, yeah, okay, it was unset, so we did jump. That makes sense. Oh, so we're not swapping these around. Otherwise, we would have swapped these around. So now it's 02, and it would have become 20. Okay. So 1 and 3 are going to be for X position, and 0 and 2 are going to be for Y position. Pretty sure about that. We're loading E into A, E being the Y position of Lolo into A. And we're going to do the same thing, right? We're going to subtract L, which is the Y position of Alma. And that's 28. And so we're going to subtract 6 and 28. It might do this minus this, but that's fine. I mean, I know it's minus 22, but I want this as a value though. That doesn't help me. Okay. I mean, the difference is 22. Let's see what it does. So it goes to DE, which overflows, which, wait, what is, I need this signed. I don't need this unsigned. So OXFF minus OXDE, oops, I'm not typing. OXFF minus OXDE is 21. Yeah, okay, that makes sense. So this has triggered the carry flag, I assume, yes, because we went over 0. We're loading A into E, meaning the difference gets put into the F register then, I guess. Oh no, it's just, no, okay, yeah. So Lola's position has been converted to the relative position. Okay. We're putting 2 and 0 into our thing here. Position 0 and 2. So this becomes 2002. But seeing as we're doing the same thing and we are not taking the jump now, so we are going to 58CD to here, but we're not doing that, right? Yeah, and now the neg is going to invert this DE to 21, I think. Yeah, so we don't take the jump because, yeah, okay, we crossed. Yeah, and that turns it around again to 22. I don't know why it's 21, why it's not 21 though. The contents of A are negated. Okay, sure. So we're taking the absolute difference because we did 6 minus hex 28, which became 22, but FF minus 22, right? So it became minus 22 and now, or minus 21, and now we go back to a positive number. Fine, which we only have to do if it's negative. That makes sense. We're loading that into, so we're overwriting that negative number. So now we have an, yeah, now we have an absolute relative distance, and we are putting 0002, so it becomes 00002222. Yeah. Are these offsets we have to do, perhaps? Okay, so we're loading D into A, D meaning the relative X difference, which is 0, and we're comparing with E. The relative X position is compared with, wait, the relative X position is compared with the relative Y position. Why would we do that? Because they can't be... Wait, can these be both? Yeah, they can both be 0. Well, no, if they're both 0, we have an interaction, like we have a collision, right? If they're both 0. Yeah, because then they're over top of each other. So this comparison is going to influence this jump. So let's see. So I don't think, is the carry flag going to be set by this comparison? It is. Okay, wait, CPE. So, wait, do we have multiple here? Because that's in red. Yeah. Subtracts E from A and affects the flags according to the result. So E is subtracted from A, but we're not saving that value, just looking at the flags. Okay. And carry is as defined. Okay. Oh, it's okay. Wait. So it subtracts the relative y from the relative x. And it's the carry flag is set. Okay, sure. Not sure exactly why. We're increasing the first value in our mystery array here. And so the y variables get incremented, right? 1 and 3. So are we jumping here? I think so, right? No, we're not. 5, 8, E, 3. So we would skip these guys here. Okay, and now we're removing. So we're undoing this, and instead we are increasing the other ones, the X ones. Does that make sense? Because we're calculating the next movement here, and I think it still has to move up. Unless, yeah, we are aligned, so I think the next movement is upwards. So Y stays the same, or do we move right here? I don't know. We'll have to see what it does. So we're undoing our two increments, okay, and we're incrementing the other ones, okay. F8 EA. So the loop starts here. We're doing something 4 times for some reason. And now we have other, no, wait. Oh, okay, now we're acting upon our calculated values here, which have become 0, 1, 2, 3 again. So we're loading the first pointer, or the first, the first pointer into HL, 1 into C, and 4 is our loop iteration variable. Okay, and the pointer to the 4th into IX for some reason. Okay. We're loading the value of the first one, which is 0, into the accumulator, and we're incrementing. And IX pointing to D2OB. Oh, yeah. Wait. D2OB, so we're pointing now here, and these values, okay, 1, 3, 7, 5, these look like directions, right? So we have 3 unknowns which look like directions, and we have our attacking skull direction, which becomes attacking mob direction, right? Because it's going to apply to almas as well. So I think we're doing calculations here in these 3, and then our end result will be this one, perhaps. So we're increasing our pointer to target D2OC, which is this one, right? And then we're decrementing A, okay. Now we're loading the iteration into that. Wait, what? C was 4. We're loading that in IX. D20C. That's this one. Why did that not do anything? Or is it a carry flag? Wait, is it a carry flag? It could be. Or I mean, oh no, it's 1 here. Okay, no, it's 1. Wait. Right, that's this one. Okay, sure. Yeah, 0401. C gets put into this position. Okay, sure. And then we're going to 3. So we're handling up direction here, right? Because this is, we're starting at up for some reason, and we're incrementing both, so that becomes 3, right? Which becomes right. And we've written that into our first position here. That's D20C, okay? So we're incrementing to make C3, which now is right. And we're incrementing HL D208. So now we're going to 9 to this one here. Okay. And now that's the end of our loop. Now we're coming back here. So we're loading the last one again, D2OB, which looks like a an offset thing though. So wait, let's see. And we're loading HL pointing now to D209, which is indeed our second thing of our 4 bytes here. Okay, we're increasing that for the future, I assume. Well, no, we loaded, we loaded 1 in there. We're adding 1 to that. That's now 2. We're increasing IX to point to D20C, which is this one. Okay. And we're removing 1 from A. Okay, that's not 0. Oh, right, but it was NC, so we do so this guy, wait, wait, where did we come from? Oh yeah, it was this one, right? Oh, we're incrementing IX a couple of times based on what the accumulator has. Okay, sure. And IX is okay. Yeah, we are indexing in this little array, which we have to end up in the second one. We are pointing at C. Now we have to end up at D. So that means we have to do it once more. Then the accumulator becomes 0, and we won't take this jump. Okay, sure. So we're just indexing into the array. Okay, that's fine. And now we're putting C where IX points, which is now here, and C is 3. So that's not going to change now, but sure. Yeah, and then we're handling again 2 more, which becomes 5, which becomes then down. But the question is, so yeah, so we're incrementing C. Now the target's movement direction is becoming down now. And we're doing it again. So we're loading 2 being this value. Okay, so this, right. These are just indexes into this little array, like 0, 1, 2, 3 are indexes into this array, and we are putting 1, 3, 5, 7 into this array based on these indexes. So I think because this is 0, 1, 2, 3, we will end up with 1, 3, 5, 7. I think. Right, so we're decrementing. We have to do that a couple of times. All right. Until, yeah, now it's 0. And we escape the loop. We increase to 7. Right. Oh, and we already updated it. Yeah, so 5. So it becomes 1, 3, 5, 7 because those are the indexes of that sequence. Okay. Yeah. So again, we load 3 being meaning index 3, 0, 1, 2, 3. Okay, we're decrementing again. That's fine. We have to do that a couple of times until A becomes 0. We do not take the jump, and we write 7 into our 4th position. Right, that's done. 7 becomes left. So I wonder if now that's going to be the definitive position that or direction we want to take. We're incrementing C. Wait, are we out of the loop? Yes, we are out of the loop, right? Yeah, okay. Okay, so that's done. We have mapped 1, 3, 5, 7 into these indexes for this array. Okay. Now we're loading 3 into B. We're looping again, I guess. Yeah, 590A. No, that loops here. But yeah, we're doing this 3 times for some reason. Okay, so that's our loop iteration index. And then we load the current AI slot direction. So we're just talking about one ALMA, of course, right? So current AI slot direction is going to be north, which is 1 up, right? Current AI slot direction is D013. Yeah, that's 1 up. We're seeing if it's 0. It's not 0. We're XORing with 4. Let's look at the calculator. So 4 is, of course, 0010. So we're looking at the third bit, or we're removing the third bit, I guess. What effect does that have on 1, 3, 5, and 7? So 1 stays, 3 is 1 and 2, those stay, 5 is 1, 2, okay, 5 becomes 1, right? And 7 is 1, 1, 1, 0, becomes 3. Did we jump to a specific location already, or do we do this every time? Okay, so XOR 4 of 1 still remains 1, right? That shouldn't change. No, that became 5. What? Oh, XOR means, wait, mistaken. I was looking at OR, not XOR. Yeah, it's either of them. So we're adding 4, I guess, if it's not set yet. So yeah, 1 becomes 5. Yeah, that makes sense. One moment. Okay, yeah. We're setting the 4th bit, regardless, and taking it away if it's set, I guess. But sure. Okay, we're loading D20C. That's still unknown, but yeah. Okay, that's our little direction array. We're comparing the value of HL, so that can be 0 then at some point. So D20C, we're comparing the value. Oh, no. So we're comparing 1 with 5, I assume, because we're comparing with the accumulator, right? Yeah, I'm gonna double check. Compare HL. Subtracts HL, the value of HL from A, and affect the flags. Okay. So yeah, that's the 8-bit manipulation. So we're doing 1 and 5. Okay. Based on the 0 flag, sure. Increasing HL, meaning we're now pointing to the second one. So we're still looking at our current direction 5, which is down. Wait, what? Oh, no, it was, wait. Current was 1, and we are setting the 4-bit, making it 5. Okay, why would we do that? Wait, I want to see what the results are of these values. So we're XORing 1 and 4, making it 5, right? Yes. So then we have the next is 3 for right. XOR 4 makes it 7. Does that make sense? 3 is 1 and 2 and 4. Yeah, that makes sense. That makes it 7. And then 5 XOR 4 takes away the 4, I think, right? Yeah, that becomes 1. 5 XOR 4 is 1. So it's rotating through the directions. Okay, and a 7 takes away the 4, means it makes it 3. Take away the 4, makes it 3. Okay, so, okay, right. Sure. So we did that. I guess we're picking a value out of these guys, right? 1357. Based on our current facing direction, we are rotating that to the next one, which becomes 5. If you have 1, you become 5. So up goes down. Oh wait, was it? Okay, I already closed my stupid calculator, of course. 1 becomes 5, so up becomes down. 3 becomes 7, so right becomes left. 5, take away the 4 becomes, so okay, we're switching up and down and right and left. Right, okay. Sure. So we're looping here. We're doing this 4 times, right? So this is now the 3rd iteration, or the 2nd iteration we're going to do. Where are we ending up? Okay, we're comparing HL. Okay, so we're looking up this 5 in this array, which is not going to be, so okay, and 5912 is an exit out of the loop. Okay. Sure. So that's not going to work. Increase HL. Now we're pointing at D20E, which is the 5. Okay, so now it's going to match. Yeah, we're comparing 5 to 5. Now the 0 flag is set, and we jump 5912. Okay. Otherwise, we would have jumped to 591D, which is right here, meaning we're not setting an attacking direction. Okay, and we exit. Okay, sure. What do we do here? So we have now 5 in our accumulator, or 3 would be like 0, 1, 2 perhaps. We need to do something with this though, because the 5 we simply calculated already by XORing. Okay. Now we're pointing to the last one. Okay, so now we're pointing to the one I gave a name, which is the attacking direction. So this we're going to move to 5, I think. 5 being down. Would they go down? I don't think they would go down now as next thing. Okay, so we're loading B into C, which makes both 1. Okay. Okay, we're loading 0 into B. Okay. And we're eldering, we're copying values. Okay, I have to look again. So we transfer a byte of data from the memory location pointed to by HL. So HL is a source. That's our direction thing here, right? That's the F1 here, the last one. Okay, from there to the memory location pointed by DE, D20E. Okay, so we're copying from here to here. Okay. And B register set 0 iterations after. Yeah. So if BC is not 0, which is 1, so we're doing 1 byte, I assume. Well, no, because we're doing 1 byte. So yeah, we're going to copy the 7 into the 5 here, I assume. Yes. And we are putting 5 into, right, it is just, okay, I think I know what it's doing. It's keeping track of the 4 last movements it did. I think that's what this is. I think. Because now we're putting 5 again there. So the 7 shifted to the left. Wait, or maybe the 2 last ones, I don't know. And that's it though. And now 5 becomes our attacking direction, which is down. So now we're going to see whether that's actually the case, right? So do we have a breakpoint here somewhere? No. know, but I'm gonna see where we called it from. Okay, return. Okay, that was called targeting AI. I don't know why that was. Oh, that was higher up. Okay. Okay. What do we do with that? So now we have updated our targeting or attacking direction, right? Targeting direction D20C. Okay, that's the base of our pointer. Oh, we're doing collision checks, I guess. See whether we can move in that direction. Yeah, I think that's what's happening here. Okay, so let's see real quick here. We're iterating 4 times. Where is our loop return? Here, 5AAF. Yeah, so we're doing this loop, this entire loop here, 4 times. Apparently for all 4 directions here, and that's also a bit weird. But yeah, okay, let's see. Yeah, so IX plus 0, and we're going to increase IX at the bottom. That makes sense. So we're targeting the first one here. We're loading A into current AI slot there. Oh, are we testing here? Because we're doing collision checks, right? Yeah, so we have 1, which is this one in the accumulator. Sure, we'll push BC, that's fine. And then skull targeting collision with environment. Okay, let's quickly look. Okay, that calls a crap load of functions here. I think this just fills in this collision variable based on what we're colliding with if we move in that direction. I think. Okay, but that's not really relevant. Okay. Okay, we're checking if we're in a bonus level, which we are not. So we jump. Okay, so why would we do this? D1EC. Okay, so that's something. D1EC. Okay, so this is checked in a bonus level. That's also interesting to look at. And then we're putting DE in the collision. DE being 1B44. I don't know why that would be relevant, but sure. We're putting our AI slot pointer into DE, putting it on the stack, and we're calling a function. Crap. Let's see, 62F4. D212. Okay, that's an unknown. Let's go in here. Checking whether it's 0. Or if it's non-zero, I guess. Oh, so we are expecting a collision value in here yet, though. D1EE, which we don't have. Okay. Okay, that's weird. What is 70 hex? No. $112. That was a number over 22. So 112. Yeah, that's 11 by 11, right? No. Or is it? Well, that's 144, right? No, 121. So 122 is 1 plus 11 by 11. Yeah. 121. Yeah. That's 7. Wait. No, 112. Okay. No. It's 112. Okay. Not sure what that is. Okay. And we're calling something again. Now it's getting complicated though. We are not looping, but 63FB, so we're skipping the increment. And we're skipping an ORing. Okay, that's a little weird little function here. Okay. Oh, are we checking map boundaries? Wait, so 121 was the first check. So I think we're checking whether we're colliding with the walls, perhaps. 5C. So first one was 70, which was 112, and then we have 5C, which is 92. And then we have 74, which is 116. Like the values are weird, and we are checking 3 of them. Well, no, 80 is checked as well. C0, E0. So wait, how many do we have here? We're calling this 1, 2, 3, 4, 5, 6, 7. 8 times. 1, 2, 3, 4, 5, 6, 7, 8 times. There are 8 blocks around us, right? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 blocks around us. That makes sense, right? And 11 times 2 times 11 is 242 over 2 is 121. Did we have 121? Wait, no. It was 112, right? 70 was 112. Yeah. So it's not an offset inside the 11 by 11 blocks. So we have 121. We have 92. 74, which is 116. 80, which is 128. C0, 192. E0 is 224. And 78. No, 78 and D4. 78. And D4. Yeah. 212. What could that be? And do we know what our incoming parameter was? I don't remember where we came in the function, so let's check that again. So we're calling 6274 and we are loading our collision thing here and our current AI slot as a pointer, and then we go to 6274. No, was it F4? Oh yeah, we're loading D212 in the accumulator, and that's what we are. Wait, no, wait. did I skip over this? Wait. Call 62F4. 62F4 is this one. I skipped over this because these are the 4 directions though. Yeah, 5173, which is loaded from the current direction. Why did I skip over this? Yeah, we're not doing all of these. We're checking when we're going in a certain direction, whether we're interfacing or colliding with one of the walls, I assume. So wait, our current direction is 1. So we are going up, I think it was. Yeah, 1 is up. Meaning we are jumping here, right? 63C0. Okay, that's way down. 63C0. Okay, that's way beyond. Oh, yeah. No. This is a different function than 63E2. Yeah, this is different. Did I miss that so completely? Because we're jumping here, right? Okay, crap. I mean, I've already skipped over the function now. But we are in or just after skull targeting. What I want to find out though is if we are now moving down, because 5 is down, right? That's what we calculated, and I'm assuming this is going to be the direction we're moving in. So we're going to move this aside for a moment here. This call 62F4. Yeah, because we're updating a position here. Let's see where we end up. So, okay. Oh, we calculated DE then. Okay. So, yeah. We're loading the current AI slot into DE. We're calling a function, and then we're putting DE back into the current AI slot, and we're not taking a pointer. We're taking the value. So we're doing the XY positions, right? So DE is now OE28, hasn't changed. Question is, are we at OE or 28 OE, or if that's the next calculated position? I mean, it still says this here as well, though. So I think it hasn't been updated yet. So this function updates our XY coordinates based on a direction. I don't know where though. I mean, it looked at this value as well. I don't know. Let's continue. Okay, that comparison does work, as in that is correct. IX is pointing to D20C, which is okay, which is our first thing here. And we're putting A into DOB2. That's, yeah, okay, so we're updating our direction here to 01. Wait, IY is DOB2. Okay, that's the base pointer. And we're adding an offset at 2. We're putting 1 in there, meaning we're still going up. Okay, so we missed the conversion from this little array to updating the mob data, right? Data array. And then we're actually updating the sprite. That's not going to happen, of course, because I'm still broken, but this one moves up. And then I don't know why we're calling that, but that's fine. We're updating the sprite. Still hasn't happened yet, of course. We're loading the current slot direction, which is still 1. But this also updates. Oh no, now we're going to, yeah. So now we're at 27, right? So we did update our position with this one as well. X and Y, I think it was. That was updated. Oh no, now we're doing it. Okay. So it hadn't already, and now we're doing it. Okay. We're loading IY is DOB2. That's the entire array of this ALMA. Okay. We're loading 1 in the accumulator, and we're putting 1 in D1FF. That's another one that we don't know about. We're loading 90. 144. Okay, that's 144. 11 times 11 is 121. So no, it's not. No. Oh no, it's the tile ID. Wait, 90 was. Wait, why would that be hard coded though? No, 90 hex is 144. Why would that be a hard coded tile ID? 144. Yeah, it is though. Why is this? Was it only for Alma? Wait, that's impossible. Because I was confused about this being, wait, or is it? No, because it's skull targeting. So I was already confused about which mob this function belonged to. And I thought it was for skulls. But now 90 is the top left of the Alma. Why would that be hard-coded? Because the first argument is our tile ID here though, so, and then the second argument is the position, which would be in HL, I assume, yeah. Which does indeed contain the next one, 26, yes. Very weird. And then we move A, and we're putting, okay, so this is something like, are we updating a sprite or something, or a tile position? I mean, this thing isn't multi-threaded, right? So I don't know why we have to keep track of that. Okay, we're calling something else. We're incrementing DOB2 to DOB8 or whatever. Or 10. Which is the fourth, okay. Yes. Very weird. I mean, we were in an ALMA non-rolling movement though. Was I this wrong? Oh yeah, no. Of course, no. I wasn't wrong in the sense that this 90 hard-coded does make sense because, where is it? Here, this one, because we are in an ALMA function. I was confused about this skull targeting, but no. This is just targeting AI, and we are in the ALMA non-rolling movement. Yeah, of course. So I'm going to, first of all, remove this, right? Skull targeting is just enemy targeting AI. And then, yeah, this is also going to be non-specific for skulls at least. So yeah, this one is just enemy targeting, and then skull targeting. This is enemy targeting. Okay. Do we have another skull reference here? Yeah, this is also wrong. I mean, they're not super unknown anymore, but yeah, this might also apply to all enemies though. and even this. This also applies to both mobs. And I don't know where this one is called. Okay. Yeah, so this 90 does make sense. So 90 would be the first one, right? The first of all the tiles. 90, no. Wait, what was 90 again? Yeah, 144 is indeed the first one of the entire range of Alma sprites, and they are being indexed, right? So I'm guessing this one gets another parameter here, though. Yeah, okay. Now we were here, so I mean the movement is going to be up though. So if I move, yeah, okay. So they did move up. That does make sense. So the only problem is we ended up here with 5, and that wasn't the direction we were like going to take, right? Which is unfortunate because we followed the entire logic behind what these values were, meaning these were indexes into this little array. But then how we got from these 4 to move up, that wasn't clear yet. Now, of course, now it's going to move to the right, I assume. So we're going to see different values though. So where are we? So yeah, if I do now go in here, we will see 0, 1, 2, 3 being different, I think. Although no, because that was dependent on our relative positioning, right? That hasn't changed. Our Y position is the same. I mean, our X, our X position is the same. Our Y position has changed slightly, but it hasn't changed top to bottom or bottom to top. So Lolo is still on top of the Almas. So I think we are going to keep 0, 1, 2, 3 here. So let's see. Okay, so we have both positions. We're doing our little jig here with the values. They're changing a bit, but at the end, we end up with 0022. But yeah, now we're going to increment them, sure. We're doing the first one. Right, 1 and 3. We are not taking the jump. Wait, did we? I think we skipped last time though. Oh, no, it's the same. It's the same. So yeah, because our relative position hasn't changed that much. We still end up with 0, 1, 2, 3. This has changed, and I think this is keeping a track of the previous positions, because I think Alma has to know that because it walks in circles, right? So perhaps we need the 4 last directions. I'm not sure. Okay, so we're going to write these values in this array, right? Are we? Yeah, we're updating, and that becomes a 7 now, I assume. Yes. No, so it's not a moving, like a rolling array of previous directions, apparently. I have to write this out in like C code so I can like keep better track of it. Okay, we were removing the 4-bit again. So yeah, we are going to the next direction again, sure. And now we're copying that to this one, which is 5 now. So we're going from 7 to 5 here. That's oh no, wait, I'm copying something else. Okay, sure. Wait, 7 becomes what? 7 is left. I thought they were going to the right, but sure, let's see. Because yeah, I don't know, 5 is our attacking enemy direction, so we are putting 5 in here. This is so confusing, like every turn. We're checking collision check. Okay, and next iteration. So, okay, we're calling this twice per. No, we're calling this multiple times. So we are going right, which is 3, which we don't see anywhere. I'm gonna have to look into that more deeply. But let's skip out of this one now. Wait, we're on in the non-rolling movement here. Okay. Do we see something that's unknown here still? Yeah, there was this one for 863. Right, we didn't know what this was, right? D234. That's this guy here. No, I want to. Wait, why do we stop here? Wait, did I put it in the wrong place? 4863. Oh, yeah, it was correct. D23B. Oh, yeah, we looked at this and we couldn't figure it out what it was. Right, D23B, and then this value mattered as well. No clue what that was. These flip-flopping values here. Yeah, we looked at this. Exits. Okay, we do have one here. Oh no, we have a couple. Let's look at this one first. B6A9. Just calls a function, okay. Oh, it's not called. Wow. Let's jump over then. Yeah, this jumps to 4356. So this happens when the game is not running. And it jumps to handle keyboard input. So we're doing something. Wait, is game running and has round started? What was that difference again? I guess whether in the whether we are in the menus or in the round. All right, so let's see. If I stop here. Okay, I'm gonna let it go now because the game is not running anymore. Yeah, wait, so it doesn't stop here. I'm going to go to the main menu. Yeah, and then it triggers. So it triggers when you die for some reason. It doesn't trigger here. Am I mistaken in my name for my variable here because it doesn't break here? Oh, did it trigger on the spacebar or wait? Okay, is this like input checking? Okay, now it does break inside the level. But perhaps only once? Oh, only once, indeed. Okay. I have to go back to the main loop. Because that's interesting. I might have misread these guys here. So has round started is true. And then, oh, okay. So immediately, okay, that jumps over everything. Okay. So if the round hasn't started, we're going to check is game running. That's perhaps the wrong name, because that doesn't really make sense in the context we've seen this. Right, so I'm going to stop again, and I'm going to control stop. So I'm going to go back to the main menu. That's weird though. So are we coming from the same position here? No, not at all. We're in different, okay, so we're in the menus now. Okay, so sure, that's fine. And we're going to start a level, and it's going to break. Okay. Wait, but has round started is what? D25C is 0. Then why did it end up here though? I should have done both. Okay, so has round started is false. Okay, yeah, because if it was true, then we jump to the keyboard input function. Okay, so the round hasn't started and the game is not running. So wait, but this name is wrong. Because is game running is false. I think I gave these guys names at separate points in time, and I think I'm thinking about the same thing, but they aren't. But as soon as I start a round, then it skips to the input function. So I can't do this in game. I have to trigger this when we're not inside a running game. So when does it trigger? Okay, so we're not in the game yet, all right? But this variable means something else though. D25D. Because as soon as I start the thing, okay, so are we now from the game loop here or what? Yeah, okay. Wait, does that one call that one too? What was the number? 4346? Well, no, because it would have put our PC on that, right? Oh, no, I escaped the function, right? Right. So this one has been called now. Okay, let's look at the variable itself. So is game running? So has round started and is game running, right? So let's stop. Okay, that's crazy. I pressed the wrong button. Oh, did I do a save state stuff? Okay, I just want to look at these values again. Okay, so they're both set to 0. And from the moment I move, they both go to 1, I guess. Yeah. So that's why I probably assumed they were the same thing, but I don't think they are. Question is, I mean, I can see what writes there, of course. Because yeah, they have two different checks here, and both So one has to be, so the round, if the round is running, we jump. And this one has, so this one has to be true to jump, and this one has to be false to jump. So we want this to be true, and this one to be false. So we have to be in a situation where this is 0, 1. And that happens when we die, I think. So if I press F8 to stop, no. No, these both get set to 0, and it's called now. And does it keep getting called? Okay, but this one jumps now, right? Yeah, this one jumps to the input function. Okay, sure. And this is going to keep happening. So this one got, the one we're looking at only got called once. Oh, because it actually, okay, wait. This one actually puts 1 into has round started. Okay, so depending on this variable, it starts the round, because it puts 1 in has round started, and it puts 1 in the accumulator and calls something. Okay, can I? Okay, wait. I'm going to disable this one. Let's see what triggers what, right? So I'm running now. Okay, we haven't started yet. If I start this one, it starts the level. Okay. Now what happens if I do the other one? Is game running? Yeah. So this one puts the round started at in motion, right? And this little timer starts counting. I don't know if that was the case if I do that with the first one. So yeah, this little timer, I don't know if this will start counted if I do this. Yeah, it does. But what's weird though is, oh no, as soon as I move, the other one gets put here too. Why would they have two separate variables to indicate that the level has started? That doesn't really make sense. And that's why they have similar names. I just saw that at a different point in time, right? Very weird. So let's see what that function does. That gets skipped or gets run only once. Because yeah, it's like, it could be like an init function that only has to happen once, but you can make that depend on one variable though. Like, why would you not? Like, what's the point of the extra variable? So yeah, so let's look what this 6BA9 actually does, if we can figure it out. So 6BA9 calls B6B5, and that's all it does, which is right below it. Okay. Okay, so we're here. So we are immediately checking the accumulator. Red M, what's red M? If the sign flag is set, we jump to the top stack entry. If the sign flag is set, that's already interesting here, because what do we give it? One. We give it 1, But that function must be called elsewhere too, right? Because this little function just calls b6b5, which is here. This must be called from elsewhere too now. So we're checking, so we're ANDing with itself, meaning we're checking whether it's 0 or not, which it's not because it's a 1, right? We're giving it 1. And we are returning if this is set, if the sign flag, was it right, is set. So let's do that again. Okay, we do this once. Do we return here? Sign flag is 0, so we do not jump. Okay. And then we jump based on the 0 flag to B6BF. That's here. So we're skipping these guys into an unknown here, DD76. That's way low. Wow. DD. Well, no, what DD76 is pointing to, right? DD76, which is EBFF. Oh, no. EBFF, which is even lower. Okay, that doesn't make sense. Do we jump here? Yes, we do. So, okay. Okay, we're doing lots of stuff here with lots of unknowns. DD55. DD76. Like, what is this? The level is already loaded, so DD77, DD79. This is weird, and we're returning here. Okay. I do want to see what happens if we remove this function, though, because this is weird. This area we can also keep an eye on. That's also interesting to look at because it does change here. There's like stuff is happening here. So that might be interesting to look at as well. We have some timer. We have very rapidly changing stuff. Okay, I want to see what happens if we do not do this function. In the game loop. So it's handled, this is executed once every level, I assume, and only once just before we start the game. Yeah, so let's see. CDA9B6, CDC543. One occurrence, that's good. And we need to remove CDA9B6. Okay, what is that gonna do? Sure. Let's exit the level. I mean, it hasn't called this function now, right? So, but now it will as soon as I start a level. I'm gonna look at the game loop again to make sure I knocked it out correctly. Yes, I did. Okay. Of course, no change. Although I don't see this stuff happening here now, though. So can we exit a level? Is this still working here? Looks like. Very weird. Yeah, so these values do not move when I remove that function though. Like, that's weird. Oh, is this music? This could be music. Because there's only one thing that happens at the start of every level, which is only done once, which is starting the music, right? So let's hear if the music's on. Okay, so in this one I have music. I don't think if you can hear it, but I have it in my ears here. I have to exit a level though. Yeah, I'll let. Okay, so I hear music. Let's see if the next one has music. I do not hear anything. That is indeed start the music. Yeah, that makes sense. Happens at the start of the level and only happens once, right? So yeah, I don't hear anything at all now. So that activates the music. Now, so that might mean that it's music related, this variable though. Well, wait, let me load the regular one. Yeah, it's. I think the one means play, as in true, run the music, but I still don't know why we have to have two variables to like, what's the distinction between these two? Like, as soon as we handle a keyboard input, it starts a level, and so the round has started. Oh, okay, and that keeps jumping. Great. Okay. Let me go back to D25D here. So these are our two has round started and as is game running. And if I do this, the game is running and there's no music. I mean, there is sound, but there is no music. Yeah. And if I, okay, so, yeah, no, it won't do it. Okay. Yeah, and now it's, okay, so sure. So I can, so now, well, the music has started, of course. Okay, wait. I have to reset. So if I put this on 1, they both go on 1. So, I mean, the only thing I can say is if I start this one, the music doesn't start. And the level is completely playable, I think. I mean, sounds play, that's fine. But I hear no music. Yeah, everything seems to work. So it's just, I mean, it's a trigger to start the sound. But if you at first, yeah, so that works fine. So it's a trigger to start a game, the round with music. Like, it initializes the music too. So does that make sense? Let me put a write point on this one. I want to see which one of those is first. And I'm assuming it's going to be this one, which then initializes the music and then turns this one on. Wait, right, because we do a check here. We want to only run the start the music once, right? So, but why would you not use the same variable though? It's a simple bool. So has round started is going to be 0. And it's going to be triggered as a consequence of start game, is game running, right? And the consequence of doing that means that all these checks disappear and we jump immediately to our input. So is game running is definitely the correct way to start a game, because it says, yes, the round is running and the music is started. Wait, I'm going to put that in a function. B6A9. Okay. Because let's assume we use this bool. Like, I don't know what the difference is between the game running and the round that started. Like, that doesn't make sense. There must be a situation in which they are different, or is this different in bonus levels? No, right? It couldn't be. Don't want to start. I mean, sure. Let's see. No, where are our variables here? I forgot where we are. Again, of course, it jumped away, and this one is gone too. D25D. Okay, has round started 0 and is game running 0. But this immediately going to be 1, right? Okay, let's put a watch point on this one. I'm curious as to what sets that. I mean, it's going to be input related, I'm assuming. Like, that makes most sense, right? I'm gonna put a write on D25D. Okay, that's not constantly set. That's fine. And I'm gonna load before one starts. Okay, so I'm gonna, okay, of course it removed my watch point. Okay, so I move and it writes it. Okay, is game running is set to true. Complete Lola half step and activate round, which is called from the handle input function, I assume. Okay. Okay, so we are in the complete half step function. So we did the half a step and we activate the level or the game. So we activate the other one. No, the main one, right? Yeah, so this is 1, this is 0. The music hasn't started yet, but it's broken now anyway. Where did this come from? Let's see where we are. If we return, oh, it jumps. Okay, 5 of 10. Update position, sure. Update Alma sprite, that's suspicious. Okay. We return yes. Okay, so that's in this function that we start the game state. Activate round, yeah, it literally says so. So at this point, oh, right. Okay, so at this point in time, this is false and this is true. So is it so that it has to skip these calls before actually starting the round? I mean, that's fine. So Alma isn't moving yet, but why would you, that's like a fraction of a frame here that we're looking at. So yeah, these things are still happening. This is false, so we do not jump. This is true, so we do not jump. We're making the round, we're setting the round start. Actually, that would be start AI, I guess. Well, no, because the snake is already moving, right? Well, not apparently here, but I mean, this one is just start music and start round, I guess. Yeah, because like the only thing that does is starting the music and then the level. It's difficult to put names on these things without knowing what they intentionally intended in 1985 or 84 or whatever. So yeah, I guess this could be seen as a trigger to start the music and the round. That's a bit weird, but sure. Like there should be a difference in between only having the start music and round trigger and has round started, because we're putting this on 1 now, sure. We're starting the music and we're immediately handling, okay, so we did move though. I guess it does a video update as well. And in our next loop, yeah, the game has started now, right? They're both 1. No idea why that difference is there. Okay, we still had some functions that we didn't know about here, which were, oh, 4863 is the same. Okay, so we call this twice and we don't know what it does, right? That's the 4863. Yeah. That was this weird thing here with these flashing variables here. No clue what that does. Also, no, I did remove them both. I was going to say I only probably did removed one and then the other one could have taken over. But I think I removed both. I mean, I can't check that though, again. So yeah, let's do that quickly. Back to the game loop. Well, no, not there. Just to be sure if we can see something that changes. Yeah, so I have to turn on the music though. Where are we? This one. CD6348 should happen twice. Okay. Okay, let's see what that does. If anything, I think we've tried this before and that didn't make any difference. So yeah, exit still works. Yeah, we remove this one and we remove this one. I mean, it could be related to a specific enemy, so we have to encounter all of them, I guess. That still works. Let's see. Medusa still works. Yes. Let's see if it affects Almas. Looks like. Yep, they don't seem to care. Wait, and it's not music related either? Nope. Oh, is it sound effects perhaps? That could also be the case. Yes, it is. It's sound effects. I don't know why there's two calls for that though. But yeah, I don't have sound effects anymore. I should have a sound effect when I pick up. Or no, is it only hard framers that contain bullets? Okay, let me play the regular level to see if that should make a sound. Okay, so I have music. I mean, this is the regular ROM, of course. So. Oh, no. Okay, these don't make sound. So it's not sound effects. Unless, I mean, I should pick up something that has a sound effect though. So for sure in the first level, why did I not have? Okay, so wait, apply the hacked ROM. Yeah, the first level has a sound effect at the first hard framer pickup. Okay, we're still in the hacked one. Let's double check. Yes, this one and this one both gone. So this one should have a sound effect. And it still has. Okay, so it's not sound effects. Yeah, no problem. Okay, so we had 4863 twice and then 5C83. That's the last one, 5C83. Exit door trigger AI started. An amount of skulls in the level. So it's skull related, looks like. Okay, so yeah, neither of those conditions are true. So we will go here because that's when it should trigger. So we need a level with skulls and the exit door is triggered. That's doable. This one. So it's still, it doesn't break. Now it does. Yeah. Okay. Immediately calling something, 5C15, amount of skulls in the level, we are looping. Maybe. Skull 2, Y position. That's weird too. Why not skull 1, right? Odd even termination. Okay, does this swap the odd even thing? Okay, let's go in here. Okay, so we're loading the amount of skulls, which is 2. We're loading that into the B register. Okay. We're loading skull 2 Y position, or like the base pointer of the second skull, not the first skull, into HL. That's DO48. DO48 is indeed skull 2, not skull 1 here. Wait, where are we? Yeah, here is skull 1, but we're loading the second one. And it's hard-coded regardless of the amount of skulls in the level. Is it so that there are only 2 targeting you? I'm not sure about that. Okay, so and we have the X state as well. That's fine. And oh, the active skull timer odd even determination. Right, that's which one of the 2 we have to work on. And 1. Okay, so we're checking whether it's 1. 5C, okay, shift right of the B1. Okay, sure. Let's divide by 2. Okay, and we return. That's also weird. So we're doing something on the odd or even iteration of the skull, like which ones we're handling, right? And this one returned 1, so we're doing something else here too, I guess, based on that result. Okay, push IY, that's fine. We're loading the value of HL. HL is pointing to the second skull here, DO48. Oh, seeing as it's odd even related, that might explain why we are referencing the second skull and not the first skull. So maybe they do something special. So yeah, we're pointing to the second skull here. We're loading the XY or the Y value into E and the X value into D. So we're getting the physical location of this skull into the DE register, which is 1C16. Yeah, that's here it's YX, here it's XY. So XY 1C16, increasing the pointer, DO49, meaning, and we're doing that twice, so we're pointing to the direction now. Okay, we're loading, so we're not loading anything yet though. We're pointing at the direction. Wait, no, DO4B. Oh, no, we're pointing to the next one, the next skull in line. Okay. We're loading IY plus 0 is D11E. That's an unknown, I think. D11. Oh, no. Oh, that's X state. Skull 2 X state. Okay. So we're loading that. We're seeing whether that's 0. So we're not doing something in case it's in X state. We're exchanging DE and HL. That's fine. Okay, interesting. Because we know what the accumulator is going to be the tile ID here, so that's interesting. So we're gonna probably know what this one does. So wait, let's see, DE and HL. HL is going to be used as a position. That makes sense, right? 1C16. And the tile is going to be flipping between open mouth and closed mouth, or the red eyes and no red eyes, I think. So let's see what's in D1FB. Yeah, right. Now we're getting somewhere. This is where the flipping is going to happen of the animation of the skulls, I think. So let's see. BC is 188. That's the skull sprite. 188. Wait, no, we were talking about tiles because the skulls aren't in here. No, skulls are not tiles, are not sprites, they are tiles. 188 is, yeah, this one here. Top left, red eyes. And that's going to alternate. So we're going to take 2 or 4. and then 184 is the other one going to be, okay, sure. So yeah, we're updating the tile here, exchanging again, that's fine. Oh yeah, and now we're incrementing IY by 2. So we're, oh no, we're popping it first, and then, which didn't change, D11E, that's X state, and we're incrementing by 2, meaning we're doing the odd ones, right? Because the X states is only 1 byte per skull. So D11E again is this one, skull 2 X state, and we are incrementing by 2, meaning we point now to IY is D120, which is this one, which is skull 4. Okay, so we're doing evens, and HL DO4B. So we started at 8 and we moved to B, which would not make sense, but now we are incrementing by 3. So we're skipping the odd one again, and we are pointing to DO4E, 4E, which would be this one. Yeah, that's skull 4. So I'm assuming that it depends on the, like we are giving the base, right? Whether we're basing the odds or the evens from the function above. Yeah. And so we're looping 5C92 all the way over here. We are looping once more, and we're looping the amount of skulls in the level. And the tile is still BC. So we're going to do the same thing. Okay, so it's going to paint them with red eyes and open mouth. Oh no, that was already done. Oh yeah, okay, yeah, we're decrementing and then checking whether it's 0. Okay, sure. And here we are flipping. Oh no, we're checking whether it's odd or even. Wait. Again, returning if it's 1 or the 2, and D1FB value. Okay, we're updating, right. We're updating the frame here now, the tile ID we have to use for the next time. So we're loading that, we're XORing it with 6, giving us the previous position. So yeah, so that's BC is now in A register, we're XORing that, and it becomes BA, and that would be the other one 8 tiles before, I guess. That's this one, 184, BA. Okay, let's write it in the thing. Here we do write it into the memory. Okay, that becomes BA, that's 186, and 186 is the mouth. That doesn't make sense. Unless, I mean, I would, like the first one was 188, was the skull, so you're offsetting from the top left part, and now we're changing it to 186 though, which is the bottom part. Unless that's what we're alternating. Oh yeah, that could be the case though. Like we do, like the eye flickering and the mouth opening happen on the alternating frames. That could be the case. So let's see if that is the case. So we return now, and yeah, okay, so we're back here. So 5C83. Okay, we're back in our thing here. So let it run. I mean, I'm gonna disable and look at it for a moment here. So yeah, the eyes don't light up. So those two top tiles stay the same. It's just the mouth movement, right? So it's just the bottom 2 tiles that change. Okay, so I did remove, again, 5C15 is going to return based on the odd even thing. Okay, so it checks the amount of skulls in the level though. I mean, I guess it just, no, it just prepares this function, right? Because we're going to use that in the thing that comes after this call, I think. So yeah, we're loading the amount of skulls into our B register, which is our loop counter. And then we get the pointer to the second skull. Well, that's still weird to me though, because we're not doing something. Oh wait, so the odd even determination, that's a timer, right? Oops. Yeah, okay, what was this? D1FA. Oh, that's the one before. Yeah, that's a counter, and it just looks at the evenness. So yeah, it does an AND with the first bit, right? So it sees whether it's odd or even, and then we jump to 5C to D. Otherwise, we do this. All right, we decrement 3 parts. Yeah. So we start at the second one. If it's either odd or even, we drop down 3 positions, right? Both HL, which points to the XY direction array, like Y, X direction. These are 3 bytes structs of 3 bytes wide, and we're doing 1 decrement of IY, which points at the X state, which is 1 byte per skull, right? So this just determines the pointers of the skulls depending on the odd-even determination of the timer. Okay, this was 5C15. Okay, so this sets HL and IY, well, A amount of skulls, HL skull XY direction struct, and IY to X state. Reload. Okay, so we can escape this function. We know what that one does. Okay, so we have these values now, and we are here. The accumulator has been put to 0 though. So that's unfortunate because I thought we were using that to loop. Oh no, it was B. And we have to do 1 iteration because we only have 1 skull in the odds and evens, right? So if you go look, do we not manipulate this? We're incrementing B. Oh yeah, shift right. So we divide by 2, right? Because we take the amount of skulls in the level, but seeing as we are doing an odd even determination, we're handling every frame, we're handling either the odds or the evens. We have to divide the amount of skulls by 2. And then if it's odd, I mean, it'll figure it out. Yeah. Yes. Okay, so then do we jump here? Yeah, no. Okay, we're saving some pointers, that's fine. And now we're loading the XY coordinates, right? We're skipping to the next one, which we then conditionally do 1 more. And we're loading the X state. Okay. Checking whether that's 0. Exchanging. Okay, and then D1FB, that's our skull. I wonder if it's only for skulls though, but yeah, this is our skull tile offset, tile ID. Like we're XORing with 6, so we're setting bit 2 and 4. Oh no, well, I mean bit value 2 and bit value 4 on and off. Okay. Okay, so let's give it a name. D1FP. We do know these guys too, though. They're missing here. D1FP is skull, or I think it's next skull tile ID based on odd even timer updated based on odd even timer. Okay. So now we know this one as well. All right. And I wonder though if this one gets set for other enemies as well. So let's look at that. Yeah, that switches between BA and BC. That makes sense. Now let's load a level that has almas in them. Well, no, almas are sprites, so that's not no. Okay, now that's not going to be the case. Perhaps these guys. No, because they just look at its position, right? No. So that's only for skulls, I think. There's nothing else that is a tile that moves. Because the almas are sprites and... Wait, were the skulls sprites? No, right? No. Because if you go look in the sprite, there are no skulls here, right? No. Yeah, there are. Wait. That's interesting. But yeah, I mean, it's going to be that's going to be the tile ID of the red eyes and the open mouth for sure. Okay, let's see where we were. Wait, I can't remember. Okay, we don't have skulls here, so let's go back to the skulls. Okay, what function called this? Oh, right, 5C83 is what we were looking at. So what did this? Wait, did I not give this a name? No. Oh, I gave the first function a name, I think. Yeah, this one. This alternates the skull tile, the activated skull tile and these. Okay, 5C83 was it? Yes. Alternate skull tiles when activated. Five C83. I'm going to disable it because I want to see whether that's actually the case that they don't have alternating tiles, or that their mouths don't open, I guess. Game loop. Where are we? Right here, alternate skull tiles. Okay, let's copy this one and knob that function out. A5, no, 5CD2, but before that CD835C. Okay, and then CD835C is gone. And let's see What happens now? Okay, I have to play the level though, but sure. I mean, I don't think the mouths should move now, but they are sprites though. That worries me. That might not be accurate then. Of course they do. Of course they move. Oh crap, now I opened it up. That is unfortunate because that's exactly what I thought it did, and it doesn't. It keeps jumping away. That sucks though. So yeah, this does not alternate the tiles though. That's weird. I mean, it literally does that, right? It literally gets a pointer to either the odd or the even skulls based on the odd and even timer. It loads the XY coordinates, it loads the X state, regardless of the X state. Well, I mean, if it's not an egg, we're loading the next skull tile ID, which we alternate here down here. So we're alternating these guys. We're incrementing, well, that's the X state increment, and this is the struct increment. And we're updating the tile at position though, like it's literally updating the tile to the next skull tile ID at that position. But then again, these are sprites, so what are we doing updating tiles? Like they are literally sprites, right? That does not make sense. And update tile at position. Also, this variable is wrong too. This needs to be the current one we're updating. Oh, and these are base offsets, I think, into the tile ID table. Yeah. Okay, so then, regardless of which ones it is, 6b23. I mean, of course, and they block, they transfer to VRAM, so very weird. Like, were they at some point in time tiles? And like, that's so weird. Okay, did that not? I thought that would activate the AI. Okay, I can't force that. I'll have to think about that. That's a bit weird. So let's note that so I can look at it next time. Okay, we're in the wrong one. And again, it jumps away. All right, let's look at that next time, because I can't figure out what else this function could be doing other than alternating the skull tiles, but sure. It must have some other function, I guess. All right, thanks for watching. Until next time.